In this problem, we're asked to conduct a poll to determine what percentage of people support a political candidate. So we're determining a percentage, which generally means that you're going to do a confidence interval to estimate the population proportion of people support her. But they've given us these boundaries, or not boundaries, but goals that we want to meet. We want to have a 10% margin of error and 99% confidence. And we need to know before we go out and collect sample data what sample size is needed so we can collect enough information when we go out and survey. So that should direct us to in this page where we have all our confidence interval formulas and hypothesis testing statistics. Down at the bottom, we have the sample size determination formulas. And notice that one is for a mean and one is for proportion. And this question is about a proportion, so we're going to want this one here. And we just need to use this formula and find the information in the given problem here. So we're going to want P, Q, E, and a critical value z-score for a two-tailed confidence interval. So usually P and Q are the easiest to find if they are given. Here it says nothing about a proportion that we think it might be. Usually you're given some proportion that came from previous research, and none was given here. So we're just going to pretend that about half the people support her, so a success rate of 50%, and that would leave the people who don't support her to also be 50%. And then our E is going to be the 10% margin of error that we're shooting for. So we'll put that in here as a decimal as 0.1. And then the critical value, we're going to need the confidence level to help us with that. So we're going to need the confidence level, and let's draw a quick sketch so we can be sure we know why we're doing what we're doing. If you draw the standard normal distribution, which has z-scores across the horizontal axis, and we're doing a two-tailed confidence interval, then we're going to have a critical value on the left and a critical value on the right that each have half of alpha in the tails. And so these two critical values are the same absolute value, or the same distance from 0. So we can get the -1 by doing norm.inverse on our alpha half, a mean of 0 and a standard deviation of 1. And then to get the +1, and this is the one we want to use in our formula because we'll be calculating margin of error, we're going to be calculating a sample size. So we want that to be positive. We can just do the absolute value, make it positive. So what we need is our confidence level, which again was given in the problem as 99%. So we have 0.99 as the confidence level, so that's 0.99 in the center, which leaves in the two tails alpha 1 minus 0.99 would be 0.01. And then that's the total in both tails, so half of that would be the area, oops, made a little boo-boo there. Half of that would be the area in a single tail, so that would be this divided in half, and we'll use that area, this 0.005, to get the negative critical value, and we'll just make it positive by putting absolute value around it. So we're going to use this area, oops, we need norm.inverse. That's how we find a boundary with a known area to the left, and the area to the left is 0.005, mean of 0, standard deviation of 1, and we have our critical value. So now all we need to do is plug all of this into our formula. So n equals, and we'll do a top and a bottom. In the top, we're going to have our z-score to the power of 2 times P times Q. In the bottom, we'll have our E, margin of error, to the power of 2. And then we always round up. Even if mathematically you would not normally do so, please always round up when you're doing sample size because you want to make sure to get enough information and not too little.